All right, Carl and I are here to talk about how we process sediment samples. And the goal of this lab and this procedure is to figure out the proportions of different grain sizes in a sediment sample. And we talked in class about the importance of grain size and figuring out what types of sediments are in the benthos in different places in the ocean, and how that's related to the abundance and diversity of organisms that we find. Today's procedure is to try to figure out exactly what those proportions are. In other words, do we have samples that are filled mostly with sand or mud or silt, which greatly affects the kind of organisms we find. So here's Carl to demonstrate one of our procedures for doing this. Now, there are different ways of quantifying the proportion of sediments of different sizes in samples. One is to put it through sieves. So we could actually use sieves and washing a sample through a sieve and quantifying or weighing the amount of different sediment types on a sieve. The other type is what we see here. So let's look at this apparatus for a second. This is called an emery settling tube. And it's a very, very long tube. And we filled it with deionized water up to the top of this tape here. And at the bottom of the tube, you can see we've got a stopcock and we've got a scale. So it might be a little difficult for you to see, but there we go. You can see that we've got basically a graduated cylinder at the bottom of this tube. What we're going to do is we're going to put our sample in this. It's going to settle down through the water, and then we're going to read the height of the settling sample at different intervals of time. And as explained in your handout, it's going to tell us what proportion of different types of sediments are in our sample. Okay, so we filled this tube with water, deionized water. We have a sample ready to go. This is a sample collected from a local beach. What you're looking at basically is a whole bunch of sand and mud in a tube. And the first thing we're going to do is we're going to take an initial height. So there's our ruler. We're going to hold that up. We're going to record the height of that sample. Right now it looks like it's about 5.5 centimeters. So that from the bottom of the tube to the top of the sediment. Record that number, and then what we're going to do is we're going to put this sample into our tube. We're going to start our stopwatch, and we're going to record the height of the settling sediment at different intervals of time, and then use that in some equations to calculate what we have in our sample. Okay, so when I say go, what Carl's going to do is he's going to plop this down in there, and we're going to start our watch, and we're going to demonstrate how this works. Okay, so 1, 2, 3, go. All right, and there goes the sample going down. You can see it settling down through the tube. And we are about to reach 13 seconds right there. And we have very little that's settled. And now we're about to reach 19 seconds. And you can see we're accumulating some sediment down in there now, about a centimeter worth. And we're going to go to 40 seconds. So we're going to wait another 12 seconds or so. You can see the sediment accumulating. And so here we go, 37, 38, 39, 40. We take another reading there. It's about 6 centimeters. Then we're going to wait for 90 seconds, and then finally 250 seconds, and calculate how much sediment is settled at that time. Now, let's look at this tube right now. You can see there's lots and lots of sediment still suspended in the water. And the physical law we're working on here is that within a column of water, particles that are larger and heavier settle at a faster rate. Now, as you all know from physics class, in a vacuum, things that are heavier do not fall faster than things that are lighter. However, in a column of water, they do. And so the sand and large particles are going to fall out first and accumulate at the bottom first. And then eventually, if we wait long enough, all these little particles of mud and silt, the very, very fine particles of sediment, are going to eventually, gravity is going to make these fall all the way down to the bottom, and we're going to record their height as well. Okay, so that's just how this works. And we're going to compare this sample of mostly sand from a local beach to a sample from the bay where there's a lot of mud in the sediment. You'll see the difference. So let's compare our sandy sample that we just did to a sample from a very muddy beach from Mission Bay. So we have to reverse that, Carl. We can't, oh, you can read it, but we can't if you don't turn that around. There we go, thanks. So we have our initial height there of our muddy sample in the tube. we're going to do the same thing we did before. We're going to pop it into our settling chamber, start the watch when it falls in.
Ready?
Anytime. All right. And then we see our mud settling down through our tube. And one thing to notice here now is going to be the less accumulation that occurs as we're hitting our initial interval. So we already passed 13 seconds, and we're passing 19 seconds right now. We have nothing yet accumulated in the bottom of our tube. And so the reason for this is that we have a very, very fine sediment sample here where the silts and clay particles are suspended in the water column and simply not falling very quickly. So even at 40 seconds, we still have very, very little, if anything, to measure down in our sample. So we're going to have to wait substantially longer periods of time, 90 seconds and 250 seconds, for there to be any accumulation at the bottom. So we're coming up on 90 seconds now for this muddy sample, and you can see we finally have something accumulated in the bottom of this settling tube, but hardly anything compared to what we saw before for the sandy sample. So remember, we have all these very fine particles of silt and clay and mud that are very slowly settling down through our water column, really illustrating the difference between the sediment at this muddy place versus the sandy sample from before.